That's your power. Then the next thing given there is that they now say what is the resistance when it's operated at what? The current voltage. Now we are being told to what? Extract resistance from here. Now remember your what? Power. What is power? Power is the rate of doing work. Power is the rate of doing work. Now if you look at it very well, we have your work done over what? T. Are you seeing it? Work done over T. That's from the definition of what? Power. That's why I said you must what? Have all the formulas in your head. This power was actually being treated in a subsequent topic. So power is what? Rate of doing work. So if you are to bring work done in here, you have your P equals, remember, work done is what? VIT. You tell them, recall. So if work done is VIT, if you bring work done into this space, you have VIT all over what? Time. So till time will cancel each other. So your power will become current over voltage. What are we asked to obtain? In the question, we are told to obtain the resistance. So from there, we can get our current from here. So remember, power is 40, voltage is what? 200. So we have 40 equals, what's the current now? That's the unknown. Now the voltage is what? 200. So my current will now be 40 over what? 200. So that gives me 1 over 5 amps. I've gotten my current. Now I now need to get my resistance. Now you now say recall from Ohm's law. What is Ohm's law? V equals what? IR. Are you seeing it? V equals IR. So my I from my result there is 1 over 5 amps. My what? Voltage is what? 200 volts. So I need my resistance now. From there I can now say, from there I can now say my resistance is what? V over I. So my V is 200. My I is 1 over 5. Are you seeing it? My V is 200. My I is 1 over 5. So when this comes here, it will now become 1000 ohms. So that will be my resistance. So we'll go to another question here. That's question 5. It says calculate the time in which 2.4 kilojoule. That's the question. That's the energy. 2.4 kilojoule. So you know that's equivalent to 2.4 exponential 3 joule. So that will give you 2400 joule. Let's proceed. Of energy, which will be expected when an electric heater of resistance 3 point, look at it. Resistance is 3.6 exponential minus 3. I seen it. Ohms with a volt of what? 240 ohms. I seen it. So we are told to now calculate the time. So we want to extract time from what? The overall definitions of overall energy, which is, we know our energy to be, recall, IVT. Are you getting it? So if this energy is time we're actually looking for, we already have, do you have current? No. So you have to obtain your current here. If V is IR, right? So from there, my current will be V over R. My V is what? 240. My R is what? That. So I'm going to say my R, or I can throw in this in here. So I will be able to have V. Let me throw it in here. So if I put it in here, I'm going to have, instead of my EIV now, I'm going to have E equals V squared T over R. You don't know how I got that? This is it. E equals, this is my I already, so it will now be V over R times V T. So V times V will give you V squared, then T R. So from there I can now say, make my T subject of formula. So my T will now become ER over V squared equals T. So from here, I'll now input all the values in that. My E is what? 2400. My R is what? 3.6 exponential minus 3. My V is what? My V is 240 all squared. So from there I'll get my time. So how do you go about this? This value cancels this. So you have 2.4 times 3.6 all over. You have all this squared time, and you have 48 now. After computing, our time here will now give us 1.5 times 10 to the power minus 4 seconds. So that is the actual time taken for all these when you use an energy of this value, resistance of this value, and your volts of this value, you extract the time, and that is the time taken. So let's proceed. Due to our time, there are so many questions there, but you can now actually practicalize all that on your own. But as regards question 6, which talks about resistivity, and question 8, question 9, they are also talking about resistivity. This is just how to break it down. Let me use that little time to break down resistivity for you. There is what we call O equals AR over L. This is just a formula you use. We have resistivity. Your A is what we call your cross-sectional area. Your R is your normal resistance. And your L is the length of wire. So with this, you'll be able to obtain your resistivity to solve question 6, question 8, and question 9. Without wasting much of our time, let's proceed to another wonderful topic. It talks about fluid at rest and in motion. Fluid at rest and in motion. Now, it's just it's not going to be anything calculated. So just sit your mind back and relax. Now, what do you mean by this? When considering fluid at rest, what do you mean by fluid? Fluid could be your diesel, your petrol, water, and what have you. So all that are examples of what? Fluid. Now, in answer, when considering fluid at rest, the following subtopics is going to be treated. Number 1, we have what we call surface tension. So we are looking at fluid at rest and in motion. Fluids at rest and in motion. If you take your bucket of water here now, there is water in it. It's not moving. You didn't pour it down. So definitely, the fluid is at rest. But if you go to your stream and you see flows of water, there is what we call water flow. Those particular fluid types are also moving. So we're looking at some characters of fluid when they are at rest, and also some other characters of fluid when they are in motion. So let's start with the ones at rest. Number 1, at rest. For characters of fluid that are in motion, we also talk about it, but let's start with the one at rest. Number 1, we have what we call surface tension. Surface tension. Number 2, we have what we call capillarity. Capillarity. Sorry, the way I pronounced it. Capillarity and surface tension. So let's start with surface tension. Surface tension is experienced when the fluid, when the surface of your fluid or your liquid behaves as if it is what? Covered with an elastic skin. What do we mean? What do you mean by elastic skin? If you look at your bowl now, if you pour, let's say this from this region downward, is being filled with fluid. Now, the phenomena whereby the surface here, this is the surface of this content. Now, the surface of this fluid then, when it's now being showcasing, as in when you are viewing it from maybe this side diagonally, or you are viewing it from this side, you are viewing it from this side. Let's say this is the eyeballs. You are viewing it from this side, and you are seeing it as if the surface is looking like a skin, or an elastic skin. It means that that particular fluid is exhibiting surface tension. Meaning that if you place a particular ball or a particular object on it, the rate at which is going to make the object to float, you understand, is very high. That definitely you say that the surface of this fluid is what? Has higher surface tension. Now your surface tension could be given by some formulas, which is your force over your surface tension is given as form which is in Newton over length which is in what? Meter. That's all. And the SI unit is Newton per meter. So that's another formula for surface tension. And we know we said the SI unit is what? Newton per meter. Now at this junction, we will be looking at some subtopics of surface tension that we need to really check. Now, under our surface tension, we said there are some subtopics, which is what we call cohesion. 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 What is meant by cohesion? And what is meant by what? Adhesion. Force of cohesion and adhesion. Now, under that, it's very simple. This is a term you eventually hear, either during this course or by the time we go higher. What are cohesion, or what is meant by cohesion? These are just characteristics that are being influenced by forces. That are being influenced by what? Forces. So, forces of cohesion now. Forces of cohesion is the bringing together of what? Molecules of what? Same substance. Cohere. Cohere. This co means what? Same. So we said under the surface tension we have a subtopic. We have a subtopic as regards the surface tension. Those subtopics are two. We have the cohesion and we have the adhesion. And we said these two subtopics are being influenced by what? Forces. So when you say forces of cohesion now, we say your co here means same. So when you say forces are just force of attraction, as in they are just attractiveness between what? Substances of the same kind. You understand? Bringing together of substances of the same kind. So if I say forces of cohesion, now, I'm talking about what?